Okay, students, a very good afternoon to all of you. So, in the first class, we are going to start with the introduction of set. This is the first topic of our syllabus, that is set theory. So, before starting this topic, the first definition is how can we define a set? What do you mean by a set? Generally, when we talk about set, we say the set of natural numbers, the set of whole numbers, the set of vowels, days of week, they all form of a set. So how can we define a set? Set is basically the well-defined collection of objects. Set is basically the well-defined collection of distinct elements, or you can say distinct objects. This is the definition of set. What do you mean by distinct? It means the element of the set will be different. In set, we cannot repeat any element. So what is set? It is basically a collection of different elements, and all the elements of that particular set will be well defined. It means in any set, we have already defined what type of elements will come under that particular set. If we want to put an example, for example, the examples of set are, the first is A is equals to 1, 2, 3, 4. This is an example of set because in this case I have mentioned all the natural numbers. What is the second example? Set of days of a week. In this set, we have only 7 elements, that is Sunday, Monday, Tuesday, and so on. So this is the basic introduction regarding set. So what is a set? It is basically a collection of different elements, and all the elements of set, they are well defined. So this is the first definition. Now let us discuss how can we represent a set. Now after definition, the second that we are going to discuss is a representation of set. Representation of set. How can we represent any set? So we have basically two methods for the representation of set. The first method is known as roster method. First method is known as a roster method. And what is the second method? Set builder method. So second one is set builder method. So set can be represented in two ways. The first method is roster method and second one is the set builder method. Now what do you mean by roster method? When we represent a set by listing all the elements, whenever we are going to represent a set by listing all the elements, अगर हम ऐसे सेट को रिप्रेजेंट कर रहे हैं या अगर हम सेट को इस तरह से लिख रहे हैं कि सेट के हर एक एलिमेंट को हम सेट में डालते हैं, so whenever we are going to represent each and every element of the set separated by commas and enclosed in the curly brackets, then that representation is said to be the roster form. So now we are going to understand this method with the help of an example. For example, set of vowels in English alphabet. Now this is the set of vowels in English alphabet, and I want to write down this set with the help of roster method. Then what is the representation? We know that we have only 5 vowels. And what are the vowels? A, E, I, O, and U. These are the 5 vowels. When we separate each and every element with the help of commas, and these elements are enclosed in the form of curly bracket, then this representation of set is said to be the roster representation of a set. So basically we have two methods for set representation. So firstly we have discussed the roster method. So whenever we represent a set by listing each and every element of the set separated by commas and closed in curly bracket, then this representation is said to be in roster form. इन जनरल मैंने बेटा यहाँ पे आपको बताया है कि जब भी हम किसी भी सेट को इस तरह से रिप्रेजेंट करते हैं कि उसके हर एक एलिमेंट को हम कॉमा की हेल्प से सेपरेट करेंगे और जितने भी एलिमेंट है उनको हम कर्ली ब्रैकेट में डाल देंगे, तो इस तरह की रिप्रेजेंटेशन को हम क्या बोलते हैं? रोस्टर फॉर्म रिप्रेजेंटेशन. सो दिस इज द फर्स्ट रिप्रेजेंटेशन. Now let us discuss the second method for representing a set. What was the second method? Set builder method. The second is set builder method. Now what is a set builder method? When set is represented, when the set is represented by using a specific property, then this representation is said to be the set builder representation of the set. For example, I have taken an example, set of natural number up to 10. I want to put an example of all the natural numbers up to 10 and I want to write down this set under set builder method. So what is its representation? A is equals to x such that x is a natural number up to 10. Also you can say x such that x belongs to n. X belongs to n means that this set will consist of only those numbers which are natural numbers and x lies between 1 to 10. तो इन दोनों में से हम किसी भी तरीके से इस सेट को रिप्रेजेंट कर सकते हैं एंड बोथ दीज मेथड्स आर नोन एज set builder method. So recently we have discussed two methods for representation of a set. First one was the set builder method and this is the second type which is known as set builder. The first one was roster method. So these two methods are clear to everyone?
Yes, ma'am.
Okay, beta. Now the next important point is, let us discuss one more example which will tell us the distinction between these two methods. Firstly, suppose I have taken an example. X is a vowel before G in English alphabet. I have taken this example and I want to mention this example with the help of both the methods, a roster method as well as by using the set builder method. Now what is this set? In this set we will consider only those alphabets which are vowels and that comes before G. Now we know in English alphabet we have only 5 vowels, that is A, E, I, O and U. So what are the vowels before E? A and E. These are the two vowels that appears before G. So what is its representation in roster method? A is equals to A comma E. This is the representation of the given set in roster form. And if I want to write down the same set with the help of set builder method, then what is the answer? B is equals to X such that X is a vowel before G. So this is an example of set, and I have used both the method for the representation of this set. First one is known as roster method and second one is known as set builder method. So basically now we have discussed the definition of set along with the two methods. First one, that is the roster method, or you can say the tabular method, and second is set builder method. Now next point is very important. What is the next point? Set is always denoted by capital letter. Set is always denoted by capital letter. This point is very important. If we want to represent a set, it means we have to use the capital letters, while the elements of set, they are denoted by small letters. They are denoted by small letters. This point is very, very, very important. If we want to represent a set, we always use capital letters, and whenever we write down the element of set, then elements are always represented by small letters. For example, A is equals to A, comma, E, comma, I, comma, O, comma, U. This is the example of set of vowels. Capital A. This is the letter which we are going to represent the whole set. And these all are the elements of set. So elements are represented by small letters, but the set is represented by using the capital letter. This point is very important. Please note it down. So these are certain important points regarding the set representation. Note it down. So the next example is, now what is the next example? Write the following set in the roster form. Let us discuss one more example. Write the following set in roster form. What is the given set? X such that X belongs to N and X is a prime number. X is a prime number between 6 and 30. Now this is the next example. We have to write down this set in the roster form. What is this set? This set will consist of those natural numbers which are prime number and they lies between 6 and 30. What are the prime number between 6 and 30? 7, 11, 13, 17, 19, 23 and 29. This set will consist of only those elements which are prime number as well as they lies between 6 and 30. Now we want to write down this set in the roster form. Roster form means we have to mention each and every element of this set. So what are the prime numbers between 6 and 30? 7, 11, 13, 17, 19, 23 and 29. Is this example clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, very good. So next is, let us discuss one example based on set builder method, and after that we are going to discuss the next subtopic. Write down the following set Write down the following set in set builder method. Write the following set in the set builder method. And what is the next example? The next is A is equals to 2, 4, 6, 8. This is the set, and we want to write down this set in the set builder form. Set builder form means we have to write down a property, or you can say a statement which satisfy all the element of this set. So what is the set builder representation of this set? A is equals to X such that X is an even natural number up to 8, or you can say before 10. There are 2 or 3 ways to write down the given set in set builder form. So I have mentioned X such that X is an even natural number up to 8, because it is very clear from element that all the numbers are even number. Also, they are natural number, and we have only first 4 even natural numbers. So that's why I have written this set will consist of those elements which are even natural number up to 8. So this is the example.
मैम up to 8 क्यों हुआ है?
Beta, in this case we have considered only natural numbers up to 8. 8 के आगे तो हमने लिया ही नहीं, 10 को तो हमने कंसीडर ही नहीं किया, तो that's why I have written up to 8. अगर आपने up to 8 नहीं लिखना तो आप before 10 भी लिख सकते हैं.
Okay मैम.
बेटा क्वेरी क्लियर है आपकी?
Yes मैम.
We have taken only first 4 even natural number, तो 8 तक की एलिमेंट रिपीट हो रहे हैं, that's why I have written up to 8. आप before 10 भी लिख सकते हो, the answer will be same. अगर x is an even natural number before 10 है तो क्या आएगा? तब भी तो सेम आंसर आएगा 2, 4, 6, 8. So the next topic is types of sets. This topic is very easy. We have also done this topic in previous classes. Types of sets. Firstly, we have discussed the definition of set along with its representation. Under representation, we have discussed 2 methods. One is the roster method and second is the set builder method. Now, what is the next topic? What are the different types of sets? The first type is null set. Null set, it is very clear from the name itself. What do you mean by a null set? A set which doesn't consist any element. अगर आपके पास एक ऐसा सेट है जिसमें कोई एलिमेंट एग्जिस्ट ही नहीं करता तो उस तरह के सेट को हम क्या बोलेंगे? नल सेट. सो व्हाट इज नल सेट? अ सेट which doesn't consist any element. A set which doesn't consist any element is known as null set. Is known as null set. Null set is also known as empty set. Also, you can say null set as empty set. So, null set or empty set is a set which doesn't contain any element. जिसमें हमारे पास कोई भी element exist जो है वो नहीं करेगा. तो इसकी एग्जांपल हमारे पास क्या है? फॉर एग्जांपल A is equals to X such that X is A is equals to X such that X is an even prime number greater than 2. क्या 2 से बड़ा कोई इवन प्राइम नंबर एग्जिस्ट करता है कि नहीं करता?
No, ma'am.
We have only single even prime number, that is 2. So there doesn't exist any prime number which is even as well as which is greater than 2. So this means this set doesn't consist any element. So this is the example of null set. Any doubt in this definition?
No, ma'am.
Okay. Also, we can quote one more example. B is equals to X such that X is a natural number and X square, this is equals to 1/4. हमारे पास कोई ऐसा नेचुरल नंबर एग्जिस्ट करता है जिसका स्क्वायर करो तो 1/4 आ जाए? हाँ जी. Is there any number whose square is equals to 1/4 and which is a natural number? No. ऐसा कोई भी एलिमेंट एग्जिस्ट नहीं करता. So there doesn't exist any element which satisfies this condition. It means again this is an example of null set. So these two examples are clear. These two are the examples of null set. And students, this definition is clear to everyone?
Yes, ma'am.
Very good. So this is the first type, that is null set, and null set is also known as empty set. Now what is the second type? The second type is singleton set. Hanji, can you define singleton set? What do you mean by a singleton set? Very clear from the name itself.
The set
Only
which
one
consists
element.
one element.
Very good. Set which consists of only single element. A set which consists of only one element is known as singleton set. कोई भी set which consists of single element, that set is said to be a singleton set. So let us consider its example. A is equals to X such that X belongs to N and X square, this is equals to 9. This set will consist of those numbers whose square is equals to 9. Now we know that this set will consist of only a single element which is equals to 3. 3 square, this is equals to 9. Square of -3, this is again equals to 9. But -3, this is not a natural number. This set consists of only natural number. And what is the second condition? X square, this is equals to 9. Now 3 square, this is 9. -3 square, this is also equals to 9. But -3, this is not a natural number. It means this set will consist of only a single element which is equals to 3. So this is an example of singleton set. So this is the definition of singleton set. A set which consists of single element. Now what is the next type? This is very common and also it is clear from the name itself. What is finite set? Hanji students.
Consist of finite elements.
Very good. A set which consists of only finite number of elements, or you can say a set whose elements can be counted, which is countable. That set is said to be a finite set. What is a finite set? A set having finite number of elements. A set whose elements are countable, that set is said to be a finite set. For example, A is equals to X such that X is a natural number and X lies between 5 to 15. What are the natural number between 5 to 15? 6, 7, 8, 9, 10, 11, 12, 13 and 14. So these numbers are countable number. So we can say this is an example of finite set. So this is very simple. Next is infinite set. What is infinite set? Whose number of element is not countable. A set which consists finite, a set which consists infinite number of element, that set is said to be an infinite set. For example, a is equals to x such that x is a natural number. Now in this case, I have not mentioned the limit. X is a natural number, so natural number starts from 1, 1, 2, 3, 4, 5, 6, up to so on. So this type of example is an example of infinite set. So these 4 types are clear to everyone?
Yes, ma'am.
Okay, beta. Finite and infinite set, these are clear from the name itself. So the next definition is very important. Next is equivalent sets. What are equivalent sets? Two sets are said to be equivalent. Two sets A and B are said to be equivalent if they have same number of elements. If they have same number of elements. So let us understand this definition with the help of an example. For example, if A is equals to 1, 2, 3, 5, B is equals to A, B, C and D. Two sets are said to be equivalent sets if they have same number of elements. Now, what are the number of elements in set A? This is equals to 4. 1, 2, 3 and 4. So set A consists of 4 elements. Similarly, what is the cardinality of set B? Again, this set consists of 4 elements. So if the number of elements in two sets are same, then we can say these two sets are equivalent sets. Now, order of A, this is equals to 4. Order means the number of element in a set. Similarly, order of set B, this is again equals to 4. So we can say A and B are equivalent sets. Any doubt in this definition?
No, ma'am.
Okay, beta. So the next definition is equal set and equivalent set. These two definitions are very important. The next one is equal sets. What are equal sets? Two sets are said to be equal set if they have the same element. Now I'm not talking about their number. Now I'm saying A and B will be equal if they have the same element. So what are equal sets? Two sets A and B are said to be equal if they have same elements. If they have same elements. For example, let us consider an example. A is equals to 1, 2, 3, 4, 5 and B is equals to X such that X belongs to N and X lies between 1 to 5. Two sets will be equal if they have the same element, or you can say if every element of set A is present in set B and every element of set B is available in set A, then A and B both the set will be equal. Now what are the elements in set A? 1, 2, 3, 4 and 5. And what are the elements in set B? Again, this consists of natural number, lies 1 to 5. Also, there is a sign of equality. It means 1 and 5 are also included. So what are the elements in set B? 1, 2, 3, 4, and 5. So A and B, they have the same element. So we can say set A and B are equal sets. So beta, kindly note down this distinction. What is the difference between equal and equivalent sets? Two sets are said to be equivalent if they have the same order, or you can say if these two sets have same number of elements. If set A and set B, their number of elements are same, so the sets will be equivalent set. But if each and every element of both the sets are equal, then you can say A and B are equal sets. That is, they have the same element. So this is the main distinction between equal and equivalent sets. Now let us discuss some more examples. And the student, please note down the first question. Show that the letters of the word cataract, C-A-T-A-R-A-C-T, cataract, and the second word is tract, T-R-A-C-T, are equal. Beta, this is the next example. We have given two words. The first word is cataract and the second word is tract. And what we want to check? We want to prove that letter